Chapter 5, we talk about exponents and polynomials. In section 5.1, we review the concept of exponents. What is an exponent? An exponent is a shorthand way of writing repeated multiplication. It takes a number and it raises it to what we call a power or to an exponent, and that exponent tells you how many times to multiply the number times itself. For instance, if I have 5 to the second power, the 5 is called the base, and the 2 is called the exponent or the power. Okay, now many times you will have a base that's a positive number like 5, or you can have a base that's a negative number. But when we have something like 5 with its 5 squared, what that really means is 5 multiplied by itself 2 times. Okay, it does not mean 5 times 2. 5 times 2 is 10, but 5 squared is 25. I don't want to write it there. 5 squared is 25. Okay, so the exponent tells you how many times to multiply the base times itself. So what if your base was -3 and it was raised to the 4th power? Then ultimately, what's the base? -3. And the exponent is 4. So what it means is the base, which is -3, times itself 4 times. Times itself 4 times. So -3 times -3 times -3 times -3 is the same as -3 to the 4th, which is equal to positive 81. Now the exponent, notice how it's a way for you to write it in shorthand, so you don't have to write all of that. So that's why we use exponents, because it's an abbreviated way of writing. Now what you have to be careful to do is to identify the base in each expression. And sometimes the base is positive. If the base is negative, if the base is a negative base, it will always be indicated by parentheses. Whenever you have parentheses around a base number, that means you have to multiply the negative number times itself over and over. If there is no parentheses, you don't multiply the negative part, you just multiply the number part, and we'll get to an example like that in a couple of minutes. Okay, so here we have to evaluate each expression. 3 to the 4th power means 3 times 3 times 3 times 3, which is what? 81. 7 to the 1st. See, you can pause the video and think about it. 7 to the 1st is just plain old 7. See, when we're in class doing a lecture, you can't pause me. You can pause me now. So pause me to think about it. -2 to the 3rd power. Remember, I just gave you an example similar to that. What's the base? The base is -2. Raise it to the 3rd. It means -2 times -2 times -2. Okay, and I'm going to move it up with it because I'm running out of space here. -2 times -2, all those are negative signs. Okay, equals -8. Notice the base is negative because the parentheses are there. Look at the next example down here. There are no parentheses here, so the base is not negative. This means you do not multiply the negative sign over and over. The negative sign kind of stays out in front. This means the opposite of 2 times 2 times 2. Okay, and what's the opposite of 2 times 2 times 2? Well, that's -8 as well, but don't get it twisted. This -8 and that -8 are -8 for two different reasons. And you'll see more of that when we work some problems in class. 2/3 to the second power really means 2/3 times 2/3, which equals, now how do you multiply fractions? Numerator times numerator, denominator times denominator, so we get 4/9. In this one we have 5 times 6 squared. Okay, but what do you do first? Remember the order of operations. Please excuse my dear Aunt Sally. That means you do all parentheses, operations inside of parentheses or brackets. It really means grouping symbols. Parentheses, brackets, braces. Then you raise any numbers to exponents. Then you do multiplication and division as they appear from left to right. Then you do addition and subtraction as they appear from left to right. Well, we have to first raise that 6 to the second power. So we get 5 times 6 times 6 is 36. Square the 6 and you get 36. Then when you multiply 5 times 36, you get 180. So we just evaluated these expressions. Okay? I'm going to run through these. These are some that we're going to do some problems in class like this to get a good understanding. But if you see problems like this in the homework, they want you to break these down into exponential expressions. So to give you a number, you write it in exponential form. For instance, 27. What number can be multiplied by itself to get 27? Or multiplied by itself a couple of times? Well, actually it's 3. And 3 times 3 times 3 is 27. And we can write it as 3 to the third power. Okay, that's the answer that would be looked for in that particular example. I'll bring this helpful hint up while I'm thinking about it. All right, let's see if we can. 7. 7 can be written as 7 to the, sorry about that, 7 to the first power. Now normally we don't write the first power. If a number is by itself, we understand the 1 to be there, but we don't write it. But for this exercise, we just do. 36 can be written as what number raised to a power? 6 squared. Now notice that was positive 36. What we have here is negative 36. So we just had an example similar to that. So the negative sign, we want it to stay out front. And then we can take 6 times 6. So it's the opposite of 6 squared with no parentheses. Nobody gets this on the first go around. So trust me, we'll get some practice in the homework and in class. 1 over 81. Well, 1 can be written as 1 to any power, because 1 raised to any power is just 1. But what about the 81? So we know we're going to have 1 in our numerator. 81 is what? What number raised to a power is 81? 9 what? Squared. So that's all. That's all they're asking. 75, well, I can't think of a way to write 75 without breaking it up into more factors. For instance, 75 is 3 times 25. 3 times 25. But that's really not an exponential expression. Which one of those numbers can we write as an exponent, with an exponent? 25, right? 3 times 5 squared. That's what they're looking for. Okay? Let me write that a little bit better. And the helpful hint down here explains to you about being careful when identifying the base of an exponential expression. Pay close attention to the parentheses. Pause it and study that, and you might want to go and try a few problems and come back to the video. Okay, notice at the bottom of the screen the same helpful hint is there for you. Let's evaluate now each expression for the given value of x. So evaluate means plug in the value that they give you for x. Now, it's very, 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 very important that you listen to what I'm saying now. Whenever, from here on out, whenever you're asked to evaluate an expression, the first thing I want you to do is rewrite the expression, and wherever you see a variable, rewrite it and replace the variable with a parentheses. In other words, write this one as 3 parentheses squared. Then go plug in the value that they tell you. The value they tell you for x is 4. Then it'll be much easier for you not to make a mistake when you're solving this particular, or simplifying this particular expression. Now look at 3 times 4 squared. What do we do first in simplifying that expression? We raise the 4 to the second power, so that gives us 3 times 4 squared is 16. And ultimately that gives us 3 times 16 is 48. Okay, so we evaluated the expression when x is 4. Now the next one has, now let's see, I want you to rewrite it, and everywhere you see a variable, put a parentheses. So we have parentheses to the 4th power over -8. And it says evaluate that expression when x is -2. Place your -2 in the parentheses and then evaluate. Okay, so look at it now. -2 to the 4th power means -2 times -2 times -2 times -2. So that's a positive 16. If you multiply all those negatives, -2, -2, -2, -2, you get positive 16 over -8, which then simplifies to -2. Once again, I want you to rewrite the expression with a parentheses for the variable. Then go back and plug in the variable, the value. So here we have 6 over, now we plug in -4, and then when we simplify it, we get 6 over, now what is -4 squared? -4 times -4 is positive 16, right? Which can be reduced, 6 over 16 can be reduced. 2 goes into 6 3 times, and 2 goes into 16 8 times. So this simplifies to 3/8. So far, so good. We're going to learn several different rules for using exponents. The first one we're going to talk about is the product rule. The product rule states that if you have 2 terms or more than 2 terms and those terms have the same base, then when you multiply those terms, you keep the base the same and add their exponents. For example, if I have x squared, what does x squared really mean? It really means x times x. What does x to the 3rd really mean? It means x times x times x. So what happens then if you multiply those two? If you get x squared times x to the 3rd, what do you get? You get that, which is x squared, times that, which is x to the 3rd, which gives us x times x times x times x times x, which ultimately is x to the 5th. But you don't have to go through all of this, right here if you know the product rule. It only works when the bases are the same. If the base is the same, like this base is x and this base is x, the product rule works. Okay? When another helpful hint, do not do what's illustrated here. Don't look at 3 to the 5th times 3 to the 7th. What you don't do is multiply the 3 times the 3. You don't do that. You keep the base the same for your answer and just multiply, add the exponents. Okay? Take a look at that, study that for a few minutes, and then move on. So here, let's use this product rule to simplify. Product rule states if you multiply two terms that have the same base, then you keep the base the same, your answer will have the same base, and the two exponents will be added. So quickly, we can use the product rule to simplify. 7 to the 3rd times 7 squared would be 7 to the what? 3 plus 2 is 5. Okay, we don't have to evaluate it, we just need to write it using the product rule. In other words, I don't really want to know what 7 to the 5th power is. I just need to know that you can use the product rule. X to the 4th times x to the 9th would be x to the what? 4 plus 9 is 13. R to the 5th times r. Now remember, r is really r to the 1st. So you still have to add the exponents. Be mindful of that. Whenever you see a number or a variable with no exponent, that exponent is 1. So this one multiplies to be r to the 6th. And it doesn't matter how many factors you have. When you multiply them and they all have the same base, you add up all of the exponents. So s to the 6th times s squared times s to the 3rd will be s to the 6th plus 2, which is 8, plus 3, which is 11. S to the 11th. Now look at this one. Negative 3 to the 9th times negative 3. Now what's the base in both of those examples? Both of these factors. The base is negative 3. The power for the first one is 9. The power for the second one is 1. Remember, there is no exponent, so it's an understood 1. So our answer is going to be the same base raised to the 9 plus 1, which is the 10th power. Let's take our product rule up a notch. Now, remember when you multiply, multiplication is what we call commutative, so you can multiply any numbers in any order. Look at this first example. We can multiply the numerical coefficients. We already talked about that. We can multiply numerical coefficients and then multiply the x values. So what we have here, there's nothing stopping you from saying, well, look, 6 times negative 2 is what? Negative 12. That would be your coefficient. Then you take your x cubed times x to the 9th, and you can use the product rule there. So x cubed times x to the 9th will be x to the 9th will be x to the 9 plus 3, which is the 12th power. Not bad, huh? Look at the next example. The next example has m to the 5th, n to the 10th, times m times n to the 8th. The numerical coefficient for both of those factors, or both of those terms, is 1. So our answer will have a 1 as the coefficient, but we don't write that 1. We understand that. So we can just use the product rule and multiply the m's and the n's. So m to the 5th times m to the 1st is m to the what? 6. And n to the 10th times n to the 8th is n to the 10 plus 8 is 18. Okay, look at the next one. We have a negative expression times a positive expression. So we know negative times a positive is a negative, and it's going to be a negative 4 will be the coefficient. Okay, then we have x to the 9th times x squared would be x to the 9 plus 2. All right, x to the 11th. And then y times y to the 11th will give you y to the 11 plus 1, which is y to the 12th. The next rule we have to talk about is the power rule. Now, the power rule is used when you have a power raised to a power. For instance, if you have x squared raised to the 3rd power. Notice it's an exponent or power raised to a power. But let me break it down for you. What does this actually mean? It actually means x squared times x squared times x squared. Do you see where that comes from? Oh, I wrote the wrong thing. Why y'all let me do that? Y'all keep letting me write the wrong thing. All right, x squared. So because the x squared is what has to be multiplied by itself 3 times. So we just did that. So now we can see where it simplifies to x to the 2 plus 2 plus 2, or x to the 6th. But who wants to keep doing that over and over every time you multiply a power like that? All you have to do is look at the power, and when it's raised to a power, you multiply the 2 exponents to get your the exponent for your final answer. Okay, so in this this definition right here, the rule for powers says whatever it is being raised to a power, if that thing itself is being raised to a power, then you multiply the 2 exponents. Okay, the example is given in variables. A to the m raised to the n power would be a to the m times n. You keep the common base and multiply the 2 exponents. Okay, so let's use the power rule to simplify a couple of expressions. 9 to the 4th, the quantity raised to the 10th power would be 9 to the 4 times 10, which is 9 to the 40th power. Okay, z to the 6th, quantity cubed, means z to the 6 times 3. Z to the what? 18th. Now look at this one. What is being raised to the 4th power here? Notice what's being raised to the 4th power. That's a base of a negative 3. Okay, the base is what you keep. So you know your answer is going to be negative 3 raised to some power. That's the base. But raised to what power? The 4 times 5 power, which is the 20th. Okay, you multiply the exponents when you raise a power to a power. Now be careful when using the power rule and the product rule. You have to make sure you understand when to apply them. Okay, I would suggest that you pause the video here and review the helpful hint that's listed on this slide. Now sometimes you're going to see expressions that are products themselves, are quotients, meaning they look like fractions, and that will be raised to a power, and you have to understand how to use the power rules for products and quotients. Well, the power of a product rule says you have a product, like AB is a product, and that product is raised to a power n. Well, what you do is when you have a whole product raised to the power, every one of the factors inside of that has to be raised to that same power. And ultimately where that comes from is like this. What if I have xy raised to the third power. What does this ultimately mean? What's being raised to the third? Xy, right? So it really means xy times xy times xy. But what happens when we multiply all of that out? What do we get? We get x to the third, using the product rule, y to the third. So there's nothing keeping us from going straight from here to here if we understand that this is a product raised to a power. You have to understand the definition. Product, meaning two numbers or more than that, or variables raised to a power. Power of a product. Okay? The power of a quotient works similarly if as long as the denominator in the fraction is not 0. So what if you have now x over y raised to the third power? What does that ultimately mean? It means x over y times x over y times x over y, which then means x cubed over y cubed. So we can go straight from this x over y cubed all the way over to x cubed over y cubed if we understand we're taking the power of a quotient and that both numerator and denominator, if they're in parentheses, must be raised to that power. So now, using the power of a product rule, let's simplify a few expressions. Look at xy, quantity raised to the 7th power, using the power of a product. Now we have the power of a product. So we know that both of those factors, x and y, have to be raised to the 7th power. So we get x to the 7th, y to the 7th. The quantity 3y raised to the 4th power, we have a power of a product. So the 3 has to be raised to the 4th power, and the y has to be raised to the 4th power. And we simplify that as 3 to the 4th, which is 3 times 3 times 3 times 3, which is 81. And I want to write that a little bit better. 81 y to the 4th. Now, this next one, everything inside of the parentheses has to be raised to the 3rd power. Okay? So, we have a couple of ways we can look at it. You can look at a negative 2 times a negative 2 times negative 2. Okay? That has to be raised to the 3rd power, so it's going to be negative 8. The p to the 4th has to be raised to the 3rd power, so it's p to the 4 times 3. Okay, so that's p to the 12th. And then the q has to be raised to the 3rd power. Q squared has to be raised to the 3rd power. So that gives us q to the 2 times 3, which is the 6th power. All right, let me see if I can change colors. Give me a blue. So the r is to the 1st power. That has to be raised to the 3rd. So we get r to the 3rd. Okay? So we've just raised everything to the 3rd power. So let's go back and Just write it all in the same color. Negative 8 p to the 12 q to the 6 r cubed. Pause it, think about it, and go work some problems and come back. Well, just like we have the power of a product, now we have to work with the power of a quotient. We talked about that a couple of minutes ago. Now let's simplify a few. So when you have a quantity that's a quotient, remember that means a fraction basically. If you have the fraction raised to a power, and both of the numerator and the denominator are included in the parentheses, you have to raise them both to that power. So here we have r over s to the 6th power. Everything to the 6th means r, means r to the 6th over s to the 6th. Simple as that. Okay. With the next one, we have the quantity 5x to the 6th over 9y cubed. All of that is squared. So let's take our time and work with the numerator. Everything in the numerator has to be squared. The numerator is a product, so we have to apply the product rule to the numerator. So we have 5 squared, which is 25. We have x to the 6th squared, which is x to the 6 times 2, which is 12, over, now the 9 has to be squared. So that's 9 squared is 81. And then the y cubed has to be squared. So that's y to the 3 times 2. Okay, y to the 3 times 2 is to the 6th. Okay, now this is a fraction. So if there were numbers in our numerator and denominator that could be reduced, we would reduce the fraction accordingly. But here 25 and 81 don't have anything in common that can be reduced, and the x's don't cancel, the y's don't cancel, so this is our ultimate simplified expression. So we've talked about the product rule, we've talked about the power of a product rule, we've talked about the power rule, we talked about the power of a quotient rule. Now we have the quotient rule. It's different from the power of a quotient. Now remember when we had the product rule stated that if two terms are multiplied and they have the exact same base, then your answer will contain the same base and you add the exponents. That's the product rule. Well, the quotient rule is similar, but if you're adding exponents for multiplication, what do you think you're going to do with the exponents for division, for a quotient? If you said subtract the exponents, you're absolutely right. But let's explain why it is the way it is. Okay, if you have x to the 5th over x to the 3rd, what that ultimately means is x times x times x times itself 5 times over x times itself 3 times. Now what happens when you simplify this? Remember, anything divided by itself is 1. So x divided by x is 1. That becomes a 1. Then this x divided by that x becomes 1s. All right. Then we have this x and that x cancel and become 1 because anything divided by itself is 1. Okay. Now, what are we left with? We are left with, don't say 2x. We're not left with 2x. We're left with x squared in the numerator and 1 times 1 times 1 in the denominator. So technically we have 1 times 1 times 1 in the numerator times another x squared. And in the denominator we have 1 times 1 times 1, which is 1. And we don't write x squared over 1. We leave it as x squared. So notice what happened. Notice what happened. You are left with x squared in the numerator. But you don't have to go through all of this once again. If you look at the initial expression, look at the 3, and I wanted to do that a different color, and look at the 5. We can simplify this a lot easier by saying, okay, well, both of those have the same base. They both are x bases, okay? And we are dividing them. So if the bases are the same, what we do with the exponents is we say x to the 5 minus 3. We subtract them, always subtract the denominator from the numerator. So you put the numerator first, and we get x to the second power. Okay? So with the product rule, when you multiply the bases, the two terms that have the same base, you add their exponents. Quotient rule says when you divide two terms that have the same base, you subtract the exponents. So let's look at some problems and simplify. Y to the 7th over y to the 3rd becomes quotient rule because they have the same base, y to the 7 minus 3, which is 4. I think this problem is not written correctly, and I can't erase it. Let me pause. Okay, it should read 5 to the 9th divided by 5 to the 6th, not 56. So, using the quotient rule, are the bases the same? Yes, they both have a base of 5. So your answer will have a base of 5. 5 to the what? 9 minus 6, which is 3. Okay? Want to go further? It doesn't say to evaluate, but we can leave it as 5 to the 3rd power here. So look at the next one. Negative 2 quantity raised to the 14th power. Negative 2 quantity raised to the 10th power. It's a quotient, and the two bases are the same. So your answer will have to have the same base, and you subtract the exponents. 14 minus 10 is 4. So we have negative 2. Be careful to make sure you put it in parentheses. Raised to the 4th power. Okay, now look at the next one. We have 7a to the 4th b to the 11th over ab equals what? So we don't have anything to cancel with the 7, so the 7 remains. Now we apply the quotient rule to the a's. A to the 4th divided by a to the 1st. They have the same base. That gives us a to the 4 minus 1, which is a to the 3rd. And b to the what? 11 minus 1, which is the 10th power. We will work. You'll get a lot more practice in your homework and in class when we discuss these various rules. Now there's something that happens that's kind of interesting when you're working with the quotient rule. And watch this. Before today, before you saw anything about the quotient rule, if you saw an expression that said 8 over 8, and you were asked to simplify that, what would you write? 8 over 8 equals what? 1. Or what about x over x? Anything divided by itself is what? 1. But that also works for terms that look like this, x squared over x squared, because anything divided by itself is 1. Well, with the exception of 0 over 0. Now, 0 divided by 0 is not 1. But that's a concept we talked about in 09 too. You can't divide by 0. But barring 0 in a denominator, any number divided by itself gives you 1, or any expression divided by itself. Any term divided by itself, any expression divided by itself. So I could have x to the third, y to the third, over x to the third, y to the third. Guess what it equals? 1. All right? Now, let's see where I want to go with this. I'm going to erase all of that. Now, you've seen that x squared divided by x squared, I just showed you, is 1. All right, so I'm going to write that again. Let's look at x squared over x squared. It equals 1. But up until today, that's probably all you knew. But today we talked about the quotient rule. Look at x squared over x squared. Can't we use the quotient rule with those two because they both have the same base and it's a quotient? So we have the quotient rule says x squared over x squared equals, let me write it over here. The quotient rule says x squared over x squared equals x to the 2 minus 2. That's what the quotient rule says, right? But what's 2 minus 2? 0, right? So it's x to the 0. Well, what kind of animal is that? What in the world is x to the 0? Well, it's called the 0 exponent, and it represents something. Now, look at x squared equals 1. X squared over x squared equals 1. And x squared over x squared equals x to the 0. Well, if that is true, if x squared over x squared is 1 and x squared over x squared is x to the 0, then that means 1 and x to the 0 have the same value. So this is what we have, the 0 exponent rule that says anything raised to the 0 power is 1. As long as that number is not 0. As long as your value of x is not 0. Sounds kind of crazy, but anything raised to the 0 power is 1. I don't care if it's a positive number or a negative number, a fraction, a whole expression, a long strung out term. I don't care what it is. If it's raised to the 0, it equals 1. So let's evaluate a few, simplify a few expressions. 8 to the 0 is what? 1. Okay. The quantity 2r squared s to the 0 is 1. But if you don't believe me, you can use the product, power of a product rule and spread this out if you want to. You can go 2 to the 0, 2 to the 0, r to the 2 times 0 is 0, and s to the 0. All of that is 1 times 1 times 1, which is equal to 1. Okay? But you don't have to go through all that because it's all in parentheses. So it's all raised to the 0 power. -6, the whole quantity raised to the 0. Because of the parentheses, we know that that evaluates to 1. That's different from this next example. Notice the negative sign is not in parentheses. So that part is not raised to the 0. Only the 6 is raised to the 0. Well, that gives you 1, but you take the opposite of that. You keep the negative sign there because it's not included in parentheses and it's therefore not raised to the 0 power. 1.9 raised to the 0 is 1. Anything to the 0 is what? 6x to the 0. Now, what are we multiplying here? X is to the 0. What is to the 0 power? Only the x, right? So that means 6 times 1, because x to the 0 is 1, which simplifies to 6. Okay? Now take some time, review that, and go do some problems, and I'll also do some in class. But now we want to determine which rules to use when given an expression to simplify. Look at x to the 7th over x to the 4th. We can use which rule? The bases are the same and it's a quotient. We use the quotient rule. The quotient rule says when the bases are the same and you're dividing, you subtract the exponents. So we have x to the 3rd. Okay, we have the quantity 3y to the 4th, all raised to the 4th power. Which rule do we use? The power of a product. Power of a product, which says you take everything, every factor, and raise it to the power. 3 to the 4th power and y to the 4th power. And 4 times 4 is 16. So we can write 3 to the 4th as 81, y to the 16th power. Now tell me which rule we use. Is it the quotient rule for x over 4 raised to the 3rd power? Quotient rule or power of a quotient? The quotient rule is used only when the bases are the same. So these bases are not the same. So we have to use the power of a quotient. Power of a quotient says you take the power and apply it to each, both the numerator and the denominator. So we end up with x to the 3rd over 4 to the 3rd. 4 to the 3rd is 4 times 4, which is 16, times another 4, which is 64. Okay? And let's look at the last few examples. Here we want to simplify 2 to the 3rd minus 2 to the 0. Well, what's 2 to the 3rd? Please don't say 6. 2 to the 3rd means 2 times 2 times 2, which is 8, minus, what's 2 to the 0? 1. So it simplifies to 7. All right. Then we have the quantity y to the 0 raised to the 7th plus 5 to the 0 raised to the 3rd. Well, just take your time and simplify each one. Well, what's y to the 0? Anything to the 0 is 1 other than 0. 1 to the 7th plus, now what's 5 to the 0? 1 to the 3rd. Right? But what's 1 to the 7th? Or if you say 7, I'm going to come get you. 1 to the 7th is 1 times 1 times 1 times 1 times 1 times 1 times 1, which is nothing but 1, plus 1 to the 3rd is 1. So this one simplifies to 2. Now, what I just did there, I don't want you to do that. I don't want you to put all those equal signs. I want you to put your equal signs below. I don't want more than one equal sign on a line. But I'm just doing this because I don't have that much room. We get 1 plus 1, and then below it we want to write 2. Okay? Now, with the next one, we have a couple of things that we have going on here. We have to use the power of a quotient, but within the power of a quotient, we have to use the power of a product for the numerator and the power of a product for the denominator. So everything inside of these parentheses has to be raised to the 2nd power. So we have 7 to the 2nd, x to the 9th to the 2nd, which is x to the 18th, right? Then we have 14 to the 2nd, And y to the 6 to the second will give us y to the 12. Well, one thing we could have done, another way you could have done it, you could have simplified the 7 and the 14 first. You see where 7 over 14 is can be simplified? In fact, I want to go back and do it that way. I like to keep my numbers as small as I possibly can. Sometimes I just get carried away working these things. But let's simplify what's inside of there. 7 over 14 is 1/2, right? So ultimately what we have is x to the 9th over 2y to the 6th. Remember that this simplifies. That's a 1 and that's a 2, just like any other fraction. But except we just don't write the 1 right here. You see what I'm saying? We don't write that 1 right there. You don't have to. In fact, if you put it in My Math Lab, it'll be marked wrong. But, so I'm going to erase that. And then I'm going to take all of that and raise to the 2nd power. Take a minute and go back and look at it and see if you can understand what I did. So, x to the 9th raised to the 2nd gives us x to the 18th. Then 2 to the 2nd is 4. Let me go ahead on and write it. 2 to the 2nd. And then y to the 6th to the 2nd is y to the 12th. So we have x to the 18th over 4 y to the 12th. And we can't simplify it any further. And keep in mind, I don't want you to write those equal signs like that. Write them going down. Don't write them all across on one line. The next one, what part of this expression is raised to the 3rd power? Pay close attention. Only the numerator is raised to the 3rd power. So only the numerator has that 3 as an exponent. But everything in the numerator has to be raised to the 3rd power. So 3 has to be raised to the 3rd. A squared has to be raised to the 3rd. That gives us a to the 6th. B to the 5th has to be raised to the 3rd. That gives us b to the 15th. All over negative 27. A to the 6th. B to the 4th. But what's 3 to the 3rd right here? Isn't that 27? Right? So we have 27, a to the 6th, b to the 15th, over negative 27, a to the 6th, b to the 4th. So ultimately, the 27s cancel. They become 1s, and we're left with a negative, because a positive divided by a negative is a negative. And the a to the 6 divided by a to the 6, they become 1s, so they cancel. And we're left with b to the 15th over b to the 4th. So that leaves us b to the 15 minus 4, which is b to the 11th. So ultimately we have negative b to the 11th. Now, we will be doing many more problems like this in the homework and in the classroom. So take your time, go back and review it, or watch the video by the author of the book and do some of the problems in your homework. And when you try them, bring the questions to class with you. Talk to you later.